Welcome to the Enigma Vault, where we unlock the secrets of lost knowledge, ancient mysteries, and forgotten science. Today, we're diving deep into one of history's most astonishing enigmas. Not a lost city or a cryptic manuscript, but a building material. Roman concrete. It's the stuff of aqueducts, temples, and architectural masterpieces that have survived centuries of earthquakes, storms, and war, while modern structures decay in decades. How did the ancient Romans build something so enduring? And why did we forget how to do it? What if I told you that the secret to this immortal material was not only discovered, but recently replicated, and it might change everything we know about construction, sustainability, and even space colonization? In this episode, we explore the chemistry, the mystery, and the modern rediscovery of Roman concrete. This is more than a story of ancient engineering. It's a glimpse into a lost science that might just save our future. The concrete used in ancient Rome, known in Latin as opus caementicium, stands today as a marvel of ancient engineering, one that has baffled and inspired scientists, architects, and engineers for generations. At the core of its mystery lies a simple question: how did a civilization that existed over 2,000 years ago develop a building material that could not only endure the ravages of time, but in many cases become stronger as the centuries passed? The story begins with the ingredients. Unlike modern concrete, which uses Portland cement as its primary binder, Roman concrete relied on a mixture of slaked lime, volcanic ash, known as pozzolana, and water. When this blend was mixed with pieces of stone or brick as aggregate, the Romans created a composite material that would undergo a chemical reaction known as the pozzolanic reaction. This reaction is key. The volcanic ash reacted with the lime and water to form strong, stable compounds that bound the mixture together at a molecular level. Unlike Portland cement, which weakens over time due to chemical instability and environmental exposure, Roman concrete formed minerals that actually became more crystalline and durable over time. But Roman engineers went a step further. For structures built in coastal or submerged environments, such as harbor walls and piers, the Romans employed a method that defies modern logic. They poured their concrete directly into seawater. Modern concrete would deteriorate under such conditions, yet Roman marine concrete hardened and became even more robust. The secret lay in the pozzolana, which triggered the formation of minerals such as aluminum tobermarite and philipsite when exposed to salt water. These minerals reinforced the matrix of the concrete and made it resilient to chemical attack from the sea. This means that, incredibly, Roman marine concrete was self-fortifying. The ocean itself helped it cure. Fast forward to the 21st century. Researchers at institutions like MIT and the University of Utah began to analyze samples of Roman concrete using advanced tools like scanning electron microscopes and X-ray diffraction. What they found stunned the scientific community. Embedded within the concrete were small white flecks, once dismissed as impurities or mistakes in mixing. Upon closer inspection, these inclusions turned out to be unreacted lime clasts, remnants of a technique called hot mixing. Hot mixing involves combining quicklime calcium oxide directly with water and volcanic ash at high temperatures. This not only caused a violent exothermic reaction, but also created lime particles that retained chemical reactivity within the hardened concrete. When cracks formed in the structure, water infiltrated and reactivated these lime clasts. The resulting chemical reaction produced calcium carbonate crystals that filled the cracks, essentially healing the damage. In other words, Roman concrete had self-healing properties, an innovation modern science is only now beginning to replicate. To test this, scientists attempted to recreate Roman concrete using the ancient formula and the hot mixing process. The results were nothing short of astonishing. In controlled experiments, cracks in the concrete began to seal themselves within weeks. Samples submerged in seawater showed extraordinary durability, resisting corrosion and degradation far beyond that of modern Portland cement mixtures. The implications of these findings are profound. Modern concrete, despite its widespread use, is fundamentally flawed. It has a relatively short lifespan, typically between 50 to 100 years, and requires frequent maintenance or replacement. Worse still, the production of Portland cement is responsible for roughly 8% of global carbon dioxide emissions due to the high-temperature kilns used and the massive scale of global infrastructure. Roman concrete, by contrast, was made with lower energy processes, utilizing naturally occurring volcanic materials and significantly less fossil fuel input. What makes this rediscovery so important is not just that we understand what the Romans did, it's that we may now be able to use their wisdom to solve modern problems. Engineers and materials scientists are beginning to experiment with Roman-inspired formulations for applications like marine infrastructure, earthquake-resistant foundations, and even extraterrestrial habitats. The dream is to build things that last, that can repair themselves, and that don't cost the Earth, literally and environmentally. In looking back 2,000 years, we may very well find the blueprint for building a better, stronger, and more sustainable tomorrow. Thank you for taking another step into our Enigma vault. We sincerely hope that you'll stay a while and explore some of our other forgotten, ancient, lesser-known, and mysterious topics. Please consider liking, commenting, and subscribing to stay up to date with our enigmatic topics.